All right, guys, we're going to review molarity and some other forms of concentration a little bit here. This is similar and based off of what our previous notes were, but I'm going to try to be more explicit about some of the questions that came up during the feedback form you guys had for me earlier this week. So, first, just in general, let's talk about what concentration is. Think about it as a strength of like Kool-Aid is a really simple example, right? If I add more powder to the same amount of water, it gets stronger, right? We'd say its concentration is increased. And the reason why is because the ratio of what you're putting in there, the amount of solute, has increased. So if the ratio to solute to total volume changes, say initially I put 1 gram and 1 milliliter, it's 1 to 1, 2 grams, 1 milliliter, 2 to 1, right? That is the reflection of concentration. And we don't really use grams, though. We use moles. So that's where a lot of this comes from. There's many different ways to measure concentration, but the one that we use in this course is molarity the most. So we're going to do solute in moles versus volume of solution. So remember, solutions are homogeneous mixture, they're evenly mixed. The solute is what I put in. The solvent is what it's in. So as an example, this is a example you've probably heard of, but like different types of drinking alcohol have different concentrations. So if you look at a can of beer as an example, different types of beer actually have different ratios. They have a percent alcohol that tells you of the total volume what percent is the active ingredient or ethanol. So the ratio is changed in there. So the example, something that has a ratio of 9.8% has a higher concentration than something that has a lower concentration, such as 6.5%. Or the amount of red dots is greater in that 9.8% than the 6.5%. Even if the amount of liquid is the same, the number of red dots in there is increased. So if I add 2 more, the concentration goes up. If I remove 2 more of those solute particles, the concentration would go down. So a couple other ways, and all you have to know about these is kind of in general what we're dividing them into, these two categories. Molarity is what we're using in chemistry. That's how we measure concentration in chemistry. These other ways are not, it's not that they are not found in chemistry, but this is the one that we're using in class. And these ones you see more often in your daily life than molarity, so to speak. So percent by mass and volume, these are often found in daily ingredients such as rubbing alcohol, hand sanitizer, percentage of nutrients, daily percent, that's by mass. You also have, as I just said, alcohol content in different types of drinks, or vinegar at the store, or hydrogen peroxide. All of those have percent by mass or volumes, what they're used. So all you have to know is what percent by mass and volume is really common in our daily life items, such as rubbing alcohols, hand sanitizer, and so forth. Okay, you don't have to know about calculations for that one. And that's the same for parts per million or parts per billion. Okay, these are often used to express ratios of chemicals in a large setting, such as drinking water or atmospheric carbon dioxide. So the concentration is expressed in parts per million or parts per billion here. So what is this used? Often used in like toxins or chemical analysis in everyday life. So that would be what you would have to know for the test on this unit. And then lastly, how do I get from the equation to the triangle in molarity? That was a question that I have. So whenever I have an equation like this, what I can do is you see this line right here? Let's just imagine that line kind of goes all the way over like this. I can draw a line right here. And then obviously this triangle is going to look really gross, but it looks like this. And if you notice, I end up with molarity down here. That's what I see here. End up liters here. And then on top, this is shouldn't be extended like that. But on top, you end up with a situation where moles is all the way over the top. So I get molarity down here, liters, and then moles. So what does this tell you to do? This tells you how you can plug them in. So very clearly, if I were to erase this, molarity is equal to moles per liter. Okay, if I want molarity, I'd take moles and I divide it by liters. Okay, so if I were to cover that up here, exit out, say I want to find molarity, that leaves me with moles over liters. Okay, now if I wanted liters, I would cover that up, and that leaves with moles over molarity. So I'd take number of moles divided by molarity. And then lastly, if I wanted, as you can imagine, moles, I would cover that up. That's what I'm trying to find. I cover up what I'm trying to find. It's molarity. Since it's next to it, that means times. Molarity times liters gives me the number of moles. And then over here is grams. So a lot of times we can go back and forth between grams, but the question is, how do I do that? And the key is we have to use molar mass. And we'll look at two examples of that. But basically, if the problem is giving me grams or asking me to find grams, I have to do a bonus step. Okay, that's the information that's being given here. All right, and we'll look at some examples now. So in general, there's kind of 3 steps that we can look at here. Try to figure out what it's giving you. So here I have 2 moles of potassium nitrate. So identify your given and your unknown. This is equal to 2 moles. That's my mole, right? That's the top part right here. So that one's given. And then I have 4 liters of solution. So 4 liters, that would be L. That's this one. So the only thing that's left is molarity. So that tells me that if I want to identify my givens and my unknowns, that means molarity is my unknown in this situation. So if I look at molarity, cover it up. So I exit out like I did before. Molarity is moles divided by liters. So I'm just going to write moles over liters. And I'll plug in my answer. I got 2 moles divided by 4 liters. Sorry, this is taking so long. I'm writing on a trackpad on my computer. That is not moles. That's supposed to be liters. 2 divided by 4 gives me an answer of 0.5. And the label there is capital M, molar. What's the concentration or what's the molarity? For 0.5 molar. And then usually you would list the salt afterwards, which is KNO3 or whatever compound is being dissolved. Okay, so identify your given and your unknown, identify your equation, and then solve for your unknown. That's really what you're doing here. This one says how many moles. That's what I'm solving for. So already I know that's what I'm solving for. I'm covering it up. So moles is equal to, since they're next to each other, you get molarity times liters. And now I'm looking at my equation. Here's my molarity, 3.5 M, and 5.6 liters. That's my L. So I'm multiplying these two. I get 3.50 M times 5.6 liters. And I actually don't have my calculator with me. I can try to plug it into my phone quick. But it's 3.5 times 5.6 gives me 19.6. We're not worried about sig figs here. 19.6 moles of sodium carbonate, Na2Ca3CO3. Okay, now, this similar type of problem is often asked, how many grams would be needed then? So if I had moles and I wanted to go out to grams, if I want to find grams, I'd have to multiply by molar mass. And the reason why is because right here, in order to cancel, moles would have to go on bottom and grams would go on top. And remember, molar mass is always some number of grams per mole. I believe for this it's 106. Okay, so if I want to solve for grams, these are just multiplying. Similarly, if I had grams and I need to solve for moles, I'd first have to go the other direction, which is divide. Okay. Since you're able to use your notes, maybe you can just write that in. So this one says, how many grams? Okay, so this is exactly like it just asked me. I want to find grams, right? So in order to get to grams, I first have to solve for moles. Okay, so that's what I have to solve for first, because via molar mass, moles are always related to grams. So moles is equal to, since they're next to each other, I multiply. I got 10 liters and 0.2 molars. So I have 0.2 m. Remember, it's molarity times liters times 10 is going to give me 2 moles. Okay, now as I said, think about setting it up like a one-step conversion. If I want to find grams, moles has to go on bottom. I'm trying to find grams of sodium carbonate here, Na2CO3. Okay. Now grams is going on top. Now molar mass by definition is 106 grams per mole. So this line right here over 1 mole is literally this part right here. It means that per mole. So 2 times 106 gives me 212 grams of sodium carbonate. Okay, so if I need to solve for grams as my final answer, I'm going to multiply. Versus this next example, if I have concentration, but I'm starting with grams, and I need to go into moles, I'm going to have to divide by the molar mass. Okay, so let's go through in the same process. Identify your given and your unknown, and identify your equation. Okay, so my givens, I have 150 grams, and I have 2 liters. And it's asking me concentration, so I'm trying to find M. Okay, so identify my given and my unknown. My unknown is M. So identify my equation. Well, to solve for molarity, I know that I need moles divided by liters. Okay, that's what the triangle or the equation tells me the equation for molarity is. Well, now the question is, well, how do I get moles? If I have grams, I can get to moles if I divide by molar mass. So just as before, whatever label I start with, and you can see where that scale comes back, goes on bottom. Grams is 58 grams here. This is really tedious on the trackpad. And 1 mole on top. So remember, you multiply by what's on top, and you divide by what's on bottom. So 150 divided by 58 is going to give me 2.59 moles. Okay, so then down here, I can plug that in, 2.59 moles divided by 2 liters is going to give me a final concentration of something a little over 1.3 molar, and then the salt is NaCl. Okay, so it's really the direction you go. Am I solving for moles or grams, or am I starting with grams? If I'm starting with grams, I have to divide to get to moles. And if I'm going back to the previous page here, if I'm solving for grams, I'm going out, I got to multiply. Okay, so it's all about the direction. Am I going out or am I coming back in? Am I going out or coming back in? And that's really how you decide. If you have questions, get in contact with me and let me know. But hopefully that cleared up some of these things for you. All right, guys, love you, miss you. Bye.